Good morning, friends. Welcome to Water Resources Engineering class. In the previous class, we covered what do you mean by basin yield, what is flow duration curve, what is its purpose. In today's class, we will take up what is basically mass curve of runoff, what is its purpose. We will look into in today's class. Mass curve of runoff. This is a very important thing. Kindly remember it for civil engineering students. Mass curve of runoff. What is mass curve? Again, curve means it is a plot. Plot between what? Flow duration curve means what is the plot? X-axis percentage of time or percentage of probability. Y-axis is a discharge. That is there. Here what is it actually? Suppose mass curve of runoff is, please remember, if suppose I take this is x-axis, this is y-axis. On x-axis, what should we take? Number one, time. This time may be, for example, 1 year. 1 year means 12 months or 20 years. That means 20 years. So like that time, months or years you should mention. Then on y-axis, it should be cumulative. Please remember, cumulative volume, cumulative flow in volume units. So previous one is what? Probability, percentage of time is on x-axis, percentage of time, not time. Y-axis what? In flow duration curve, it is discharge, meter cube per second. Here it is not that. On x-axis time, maybe month means January, February, March, April, like that. Or years means 9, for example, 2000, 2001, 2002, 2003, like that. You can take on x-axis. And on y-axis, you have to write cumulative flow, cumulative runoff in terms of which units? Volume units. Please remember. A mass curve is a plot. It is nothing but cumulative runoff. Very, very important. Volume, not meter cube per second versus time. This is the next thing. Now, what for we use it? This mass curve is essential for determining the storage requirements. If you are constructing any reservoir by constructing a dam, how much storage is possible? So that storage capacity you can find only using mass curve. Then next, it helps in analyzing the water availability for demand based on the demand. Then basically, how to do it actually. For example, collect the discharge or runoff. If suppose you get the discharge, convert into volume units, right? Then after that, calculate the cumulative volume. Time versus cumulative volume, you put it, you get the mass curve. How the mass curve will be, for example, if you draw, it will be like this. So it is always a rising curve. Why rising curve? Because it is cumulative value. That means plus only. For example, in a mass curve, at any point, if suppose you are finding out like this. So this horizontal indicates there is no runoff actually. There is no inflow. So that's why it can be always increasing, or maximum it can be horizontal and then increasing. So that is what you should remember. So it is always a rising curve. So fundamentally, then once you plot the mass curve, after the mass curve, you plot the demand curve. So on the same plot, once you plot the demand curve on that, then we can find out the storage capacity. Suppose this is the mass curve which we are getting. On x-axis, what we have taken? Year. On y-axis, it is cumulative inflow. Please remember, cumulative inflow volume. That's why it is hectare meters. Hectare means 10 to the power of 4 meter square into meter. That means hectare meter means, what do you mean by hectare meter actually? Hectare meter is equal to 10 to the power of 4 meter cube. So that is why the always on y-axis it is cumulative runoff volume. Now we have plotted the graph. So this is the graph which we obtained. So this is how the graph is obtained. So this is what we call it as mass curve. See, anywhere there is any going down, no way. It is always rising, or maximum sometimes it can be horizontal. So first do that. Once you do that, next one what? You find out the demand. That means when once you are constructing something, first what for you are going to construct? To meet the demand. So now wherever you are constructing this reservoir, you find out what is the acreage that you want to produce a crop. How much is the water requirement? How much population is living there? How much is the drinking water needs? How much power you want to produce? So like that, you take all the requirements, and from the requirements, you calculate the demand. So what is the demand per year? So here I have taken actually, this is 72, 73. So that means this is 1 year period, right? For this 1 year period, what is the demand I should calculate? And that calculate means either that for your exam purpose, they will give you the demand, or otherwise field, how you will do? You need to think when a particular reservoir is coming. Okay, this reservoir has to serve this much population. This reservoir must really give crop production in this much area. This reservoir must produce this much power. Based on that, you calculate the demand. So put the demand as a vertical ordinate like this. If you join this, right, what is this? This nothing but the slope. The slope indicates the rate of demand. That is what is called as demand rate. So that you do it. So what you have done till now, whatever data that is being given, you have taken, calculated, if discharge is given, you calculated the volume. Then after calculated the volume, depending upon the time period, you calculated the entire thing, cumulative volume. Once cumulative volume is obtained, you have taken the year on x-axis, you have taken the cumulative volume on y-axis, then you have plotted the mass curve. Once the mass curve is plotted, next what you have done? On the same graph, you have taken actually the demand. Demand actually you have taken, and demand rate also you have taken actually. So the slope indicates the rate of demand. Once that is done, next what you should do? So you have already the mass curve, you have already the demand curve, both are plotted on the same graph. Now next what? Identify the peak points of the mass curve. So this is one peak point, this is another peak point, this is another peak point. So if I see in this mass curve, there are three basically peak points. What I should do? Draw a tangent at this peak point. What I mentioned? Draw a tangent at this peak point parallel to the demand line. So already demand line is, this is the demand line. Parallel to this line, draw basically a tangent at this point. Similarly, draw a tangent here. Similarly, draw a tangent here. After drawing the tangents, what is the vertical ordinates? You just see. The vertical ordinates are nothing but the requirement of the reservoirs. Out of three, whichever is maximum, that becomes the storage capacity of the reservoir. You followed the steps? Generally, monthly or yearly data is given to you. That data is in terms of discharge units. Immediately you need to convert into volume units. Then you need to calculate cumulative volume. Take on x-axis the month or year and on y-axis the cumulative volume. Then draw the mass curve. After the mass curve, see the demand whatever is being given. Then take 1 year or 1 month period. Vertical line you draw equal to the demand. The slope of the demand line indicates the rate of demand. Identify the peak points of the mass curve. Draw tangents at these peak points parallel to the demand line and identify what is the vertical ordinates. The maximum of the vertical ordinate becomes the reservoir capacity. That's it. Now let us study some more important points of the mass curve. For example, if you see, when I am extending this line, the peak is here, whereas the demand is here. So what do you mean by that? At this particular point of time, this is the only, basically, this is extra because already this much volume is there and your demand is only this much. Totally this much is available, but demand is this much only. So naturally, this part is excess. That's what in the previous case I mentioned actually. If you see, if demand line falls below the mass curve, if the demand line is below the mass curve, all the demand can be met, no issue at all. If the demand line lies above the mass curve, then reservoir is required. Reservoir is required means storage is required. So depending on the demand line is below the mass curve or above the mass curve, we need to follow it. Suppose here you see the demand line is above the mass curve, so reservoir is required, storage is required. Here suppose if you see the demand line is basically below the mass curve, then you don't require any storage at that point. So this is what finally how to draw a mass curve, how to find the storage capacity of a reservoir. Take a problem. The mean monthly runoff values from January to December in a leap year, very important, in meter cube per second, only discharge units he has given. Determine the minimum storage required to satisfy a demand. Demand also that fellow has given. Everything is known. So January to December I have written. What is the monthly flow I have written. Number of days in a month, you know it actually depending on the month. February 29, except that remaining months you know 31, 30, right? What is the monthly flow volume? Flow volume means this multiplied by this will give you this. So meter cube per second is also called as cubic. Cubic is nothing but meter cube per second. So multiplying both 60 into 31, 60 into 31 is equal to this much. Like that we have calculated. Then accumulated means cumulative. Cumulative volume is this. So what is the thing? Discharge is being given. Immediately what you should do it? You should know what is the basically you convert into volume units. So already volume units. After converting the volume units, cumulative volume. This is the first step of a problem. Then second step of a problem is what actually if you take it, take a graph sheet. Take a graph sheet. Right on x-axis, what is the thing? Monthly. January, February, March, April, month. And on y-axis, you should accumulated inflow volume that we have taken, right? Then plot the mass curve. Already the values are there. We have plotted. This black line, complete thick line indicates the mass curve. Fine. Over. Next. How to plot the demand line? Demand line is equal to, I have taken 2 months period. So 2 months, one straight line I have drawn. So for 2 months, what is the thing actually? How many number of days are there in 2 months? 31 plus 30, 61 into what is the demand he has mentioned? 50. So 61 into 50 I have put it we got this, how much is the volume, I got it. So now I join this much vertical ordinate, we need to keep it. After keeping the vertical ordinate, you join these two. And this is what it indicates, it is the slope of the demand line. And this is also called as rate of demand. Right? Now what you should take it, now if I see the entire graph, there is only one peak, I got it. So at that peak, what I need to do, draw a tangent parallel to this RP. So that is what we have written it actually here. At this point, we have written this, right? Then there is no other peak, so no way. So what is the ordinate? So that ordinate is nothing but this indicates the reservoir capacity. So this is the way which we follow. We have mentioned the stepwise procedure also. Calculate the cumulative runoff in terms of volume units. Take a graph sheet and plot the mass curve. Time is on x-axis and cumulative runoff volume is on y-axis. Plot the demand curve on the same graph sheet. The slope of demand curve line indicates rate of demand. Identify the peak points. Draw tangents at the peak points. Measure the vertical ordinates. Maximum vertical ordinate is the reservoir capacity. So comparison, if I make it both the things, both flow duration curve and mass curve, if I make a comparison, then naturally x-axis what you will take in flow duration curve, percentage of time flow is equal or exceeded, whereas on y-axis time, maybe days, maybe months, maybe years. On y-axis what you will take, discharge in meter cube per second, and here what you will take, it is runoff volume. What is the purpose? Flow variability here. That is main important point. Here it is what actually the reservoir capacity determination or storage analysis. And what is the data required? The discharge here. What is here data? Time series runoff volume. So applications of flow duration curve, especially in hydropower and a dependable quantity of water. These are the two main things. Mainly reservoir design and what is the demand planning. This is the thing. So these are the comparisons of flow duration curve and mass curve of runoff. If I say mass curve means always mass curve of runoff. So that completes to me the lecture part 3 of runoff actually. With this, we will close the topic here. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.